We are discussing IIT-JAM 2018 Modern Physics problem. This problem is related with the hydrogen atom. Let Tg and T be the kinetic energy of the ground and third excited state of hydrogen atom respectively. According to Bohr model, the ratio is according to Bohr's theory, energy of electron in hydrogen atom is given by En is equals to minus R infinity Hc by n square. The kinetic energy electron given by T is equals to En by 2, that means minus R infinity Hc by n square into 1 by 2. The kinetic energy of ground and third excited state is are Tg equals to minus R infinity Hc by 1 square into 1 by 2 and T equals to minus R infinity Hc 4 square to 1 by 2. So Tg by Te is equals to minus R infinity Hc into 1 by 2 divided by minus R infinity Hc by 4 square into 1 by 2, that gives us 16. The mean momentum P of a nucleon in a nucleus of mass number A, atomic number Z depends on Az edge. So we have to determine dependence of momentum on atomic number and mass number. According to HUP, Heisenberg uncertainty principle, del R, del P must be greater than H cross by 2 implies del P must be greater than H cross by 2 into del R. Same can be written as P must be greater than H cross by 2 R, and R is nothing but R naught a to the power 1 by 3 2. So P must be proportional to a to the power minus 1 by 3. Hence our option C is correct. A particle of mass m is in one dimension potential Vx defined like this. At some instant its wave function psi x is given by 1 by 3 psi 1x plus I2 root 2 by 3 psi 2x, where psi 1 and psi 2x are ground and excited state, which identify the correct statements. One can see that in this problem energy are different in all options. So if we correctly identify the energy, we can mark the correct option irrespective of whatever is value of delta x. We just check it out, the energy. We have psi is equals to 1 by root 3 psi 1x plus I root 2 by 3 psi 2x. Further, psi dot psi equals to 1. That means psi is normalized. Expectation average energy eigenvalue is given by E is equals to summation EI PI. That means 1 by 3 of E1 plus 2 by 3 of E2. That means 1 by 3 E1 is pi square h square by twice m l square plus 2 by 3 into 4 pi square h square by 2 ml square. So we would be having it average E is equals to 9 by 3 pi square h square by 2 ml square. That means 3. So we can write h square by twice m 3 pi square by l square. That means our option is correct for this problem. A system of 8 non-interacting electrons is confined by a 3-dimensional potential Vr is equals to half m omega square r square. The ground state energy of the system in unit of h cross omega is. Solution. The degeneracy for 3D harmonic oscillator is given by Gn is equals to 1 by 2 n plus 1 into n plus 2, and its energy En is equals to n plus 3 by 2 h cross omega, where n is equals to nx plus ny plus nz. Now let us place the state. How many states are there? For n is equals to 0, what is the degeneracy of state? For n is equals to 1, what is the degeneracy of state? And we have to place the 8 non-interacting electron. So for n is equals to 0, Gn would be 1 by 2, 0 plus 1 into 0 plus 2, that is 1. For n is equals to 1, degeneracy would be 1 by 2 into 1 plus 1 into 1 plus 2, that is 3. So for n is equals to 0, we would be having 1 state. For n is equals to 1, we are having 3 degenerate states. So let us place the 8 particle in these states. 2 occupies in this, 2 occupied in this, 2 occupies in this state, 2 occupies in this. Now the energy for n is equals to 0 would be En for this would be 3 by 2 h cross omega, and E0, now E1 for this would be 5 by 2 h cross omega. So the ground state energy of the system is given by E0 would be 2 times into 3 by 2 h cross omega plus 6 into 5 by 2 h cross omega, that is 18 h cross omega. So our answer for this is 18 h cross omega. So numerical value is 18 for this problem. A particle of mass m is moving in a circular orbit given by x is equals to r cos omega t, y is equals to r sin omega t as observed in an inertial frame S1. Solution in frame S1, x is equals to r cos omega t and y is equals to r sin omega t. Another inertial frame S2 moves with uniform velocity v omega ri with respect to S1. So let us discuss. This is frame S, x, y. This is frame S dash, x dash, y dash, x dash. It is moving with velocity v. Now S2 are related by Galilean transmissions such that origin coincide. The magnitude of angular momentum of particle at t is equals to t pi by omega as observed in S2 about the origin is expressed as. So let us write in frame S2 the position vector is given by r is equals to x minus vt I plus yj, that is r cos omega t minus vt I plus r sin omega t j. V would be del r by del t, that is minus r omega sin omega t minus v I cap plus r omega cos omega t j cap. Thus angular momentum is defined as L is equals to R cross P, that is M into R cross V, that is M R cos omega t minus Vt I plus R sin omega t j cap cross minus r omega sin omega t minus v I cap plus r omega cos omega t j cap. So if we take the cross product, we get it m omega r square cos square omega t minus vt r cos omega t plus r square omega sin square omega t plus v r sin omega t k cap. This is further simplified to m r square omega plus Vr sin omega t minus Vtr cos omega t. So L at t is equals to 2 pi by omega. L would be m r square omega plus Vr sin omega into 2 pi by omega minus V into t 2 pi omega into r cos omega 2 pi by omega. Further V is r omega. Here one term omega is there. So omega would cancel out. We would be having it. The cos 2 pi would be 1. We can take it out. M r square omega outside 1 minus 2 pi. So this term is equals to minus 5.28 m omega r square. Our mod L is equals to 5.28 m omega r square. Thus, this term x is 5.28. This problem is related to the special theory of relativity. A rod has rest length 1 meter and rod 2 has rest length 1 meter. R1 and R2 are moving with respect to the laboratory frame with velocities Vi and minus Vi. In laboratory frame R1 is moving with Vi and R2 is moving with minus Vi. In rest frame of this, so in rest frame of R1, let R1 this R2, so this is R1 is a rest frame attached with in which S is a rest frame in which R1 is at rest and R2 is moving with velocity minus Vi. In this frame, the length of R2 is 1 meter. So the length of R2 in rest frame of S is 1 meter. So we can say it L is equals to L naught into 1 minus ux square by c square, where L is equals to 1 meter and L naught is equals to 2 meter. The velocity ux of rod in rest frame is given by ux is equals to ux dash plus v divided by 1 plus ux dash v by c square. Further, ux dash is minus v and v is minus v. So here you would be having it minus v divided by 1 plus minus v into minus v by c square, that is minus 2v divided by 1 plus v square by c square. So substituting value of ux in the expression of L, we get in the expression of L, we get L is equals to L naught 1 minus 2v into 1 plus v square by c square k square divided by c square, which can be written as L naught root over minus 4 beta square divided by 1 plus beta square. So, or 1 by 2 is equals to root over 1 minus 4 beta square divided by 1 plus beta square का square plus beta square का square, or 1 by 4 is equals to 1 minus 4 beta square into 1 plus beta square का square, that means 4 beta square 1 plus beta square का square is equals to 1 minus 1 by 4 implies equals to 3 by 4. So we can write it down, implies beta over 1 plus beta square is equals to root 3 by 4, or 1 plus beta square minus 4 by root 3 beta equals to 0, implies beta is equals to 4 by root 3 plus minus 16 by 3 minus 4 divided by 2, which give us 4 by root 3 plus minus 2 by root 3 divided by 2 is equals to beta equals to 2 by root 3 plus minus 1 by root 3 equals to root 3 into 1 by root 3. So v by c less than 1 is equals to, since v by c should be less than 1, that means beta should be 1 by root 3, which means this value is 0.577. So our correct answer for this problem is 0.577. Two events even need to take place in an inertial frame S with respective time-space coordinate in SI units. E1 t is equals to 0, R1 0, and T2 is equals to 0, x2 10 की power 8, y0, z0. Another inertial frame S dash is moving with velocity with respect to S with a velocity t0. The time difference t2 dash minus t1 as observed in S dash is. So this is frame S, this is S dash moving with velocity v. Now two incidents happen simultaneously. This is x1, this is x2. So here maybe you can set it two flashlights are emitted simultaneously. So what's the time? Delta T. A person observed in frame S dash. The time coordinate frame S dash are given by T1 dash is equals to gamma T1 minus Vx1 by c square. T2 dash is equals to gamma T2 minus Vx2 by c square. Hence, T2 dash minus T1 dash equals to gamma T2 minus T1 minus V by c square into x2 minus x1. That means gamma V by c square into x2 minus x1 as here delta t equals to 0. ठीक है? So delta t is equals to 1 over root over 1 minus 0.8 square into V 0.8 c 8c into c square into 10 to the power 8. So c would cancel out 0.8. In denominator we would be having 0.6 into 10 to the power 8 divided by 3 into 10 to the power 8. That means 8 by 18, which is equals to 0.44 second. So answer is 0.44 second.